We have got so much to show you today. So welcome to the March edition of the community call. We've really got a absolutely full show. So I'm going to go ahead and just go right into these slides, and then we're going to start off with our first bit of content here in just a minute. So first things up, my name is Jesse. If you haven't seen me before at the previous calls, I do some more technical stuff here in terms of community outreach. If you have any questions, find me on all the platforms and I will connect you to the right person at Hasura. I will make that as a quick opportunity to apologize that I have been saying the name wrong for the last year and a month or so. So Hasura as opposed to Hasura. So yes, say it all with me, everybody. Hasura with an S. There we go. All right, get that out of the way. So I'm Jesse, and today this is what our agenda looks like. First up, we're going to have a fantastic update as always from Tanmai. And then we're going to be getting a new section to these community calls called HasuraEd, where we're going to be doing a deep dive look as HasuraEd, deep dive look at the features inside of the product. So a specific angle, a specific concept. We're going to do a real, just deep look at how that works, what's coming up, and that'll be a lot of fun. So definitely stand by for that. We'll hear more about what the upcoming versions of that will be. We're going to have a look at multiple JWTs, which is going to be a really interesting talk as well. Better comments in schemas. We're going to have a look at relations on actions, and then Prometheus in action. And then we have a really great community showcase from Chris Nurse. We have 4 Australians on today's presentation. So talking about distributed and all around the world, that's going to be a lot of fun. So this is the unofficial Down Under community edition. But with that being said, I'm going to go ahead and hand it over to Tanmai to give us the sort of overview and the quick updates, and then we're going to go right into the streaming subscriptions.
So I'm gonna actually dive right into streaming subscriptions and take you folks over an update there because that's going to take a fair bit of time. So let me dive in straight with that. We talked a little bit about streaming subscriptions. I'm going to just do a little more of a kind of a little bit of an update on kind of where we are, do a little bit of a live demo. We'll get to try it out a little bit and talk through kind of a few use cases and our rationale also behind that, right? So in general, the need for kind of streaming data has been going up for all kinds of applications, right? The two broad categories, right? The first is that we have a large amount of information, which is fast, that needs to be consumed within a short window of time, right? Like, for example, you might go to a particular page and you want to see logs, right? Like you have a build running and you want to see kind of build logs that have happened at that period of time, right? Or there's a ticker that's kind of moving and you're interested in that quote unquote real-time information, right? Obviously, those kinds of events and changes are things that you want to stream, and you're only interested in that stream within that window, right? When you're looking at it, but you need it to be a real-time stream. Chat messages are another great example of like you want to be able to see, and it's especially fast moving, so you want to be able to see that stream happen as you consume it, right? But also the same streaming kind of paradigm comes in. Even if that information that you're consuming is not necessarily fast moving, but it actually might be just a large amount of data, right? And you need to kind of ship that large amount of data over an API, right? And these are kind of like data extraction kind of use cases, or in the good old days where you would just FTP it, and hopefully not all of us have seen too many of those good old days, but maybe you copy a file over essentially, right? Or like share this gigantic piece of data, and then it becomes the easiest way to share the data is like chuck it in a file and then have folder sharing, right? But the API first alternative is increasingly kind of becoming important, right? Because you still want to have an HTTP API, you want to have a JSON API, you want it to be secure. So a part of the challenge when it comes to streaming is that some of the underlying technology for persisting the streaming information exists, right? To persist the stream, that's fine, whether it's a database or a stream queue or whatever, that still exists. But a part of this API challenge is that it's hard to consume this information also, right? And that's kind of where GraphQL and subscriptions are a good fit. But again, just to kind of recap why you have, you want things to be over HTTP because HTTP is nice. Security is figured out. Everybody in the entire ecosystem, the entire stack knows how to reason about security. Everybody can reason about HTTP can be stateless, which means that clients can connect and disconnect, and that's kind of built into the protocol itself. And of course, there's a tremendous amount of tooling through the entire stack, but especially on the edge side and on the client side, right? Streaming is also hard because a key part of consuming a stream is the ability to manage back pressure. In fact, one of the first reasons why when we launched subscriptions and GraphQL subscriptions, we only did live queries is because the story around back pressure is hard, right? In a live query kind of model, it's easier to subscribe to an object as it changes because you know that you'll only get you'll get the latest value of that object. But suppose it's a stream of data. You want to make sure that if you're consuming a stream and the stream contains 1 million events, your client can give feedback to the streaming producer, to the streaming server, and say, hey, I've gotten way too many events and I'm dying because my memory is overloaded, or I can't fill up my data structures fast enough. And so please slow down or please pause, right? And this ability to manage back pressure is also really important. Otherwise, you're just going to overload clients and kill them, right? And then, of course, part of kind of being stateless is also that you want to be able to recover from disconnects and not miss data, right? So these kinds of things are things that make it challenging when we think about consuming a stream, because these problems need to get solved, right? And of course, you want to make sure that when you're streaming, the system that is sending out the stream can also solve the same problems, right? The problems of being able to, all of those kind of primitives that the clients need to manage back pressure and to manage disconnect and stuff like that. But then also you want to make sure that you're able to handle like authorizations. So you're able to, at a stream, within the stream, subscribe to or stream only those parts that you have authorization to be able to stream, right? And you're able to enrich parts of that data, parts of that stream data that you can that you might want additional information on. As an example, with one of our users and customers, we're kind of working on this use case where there's a mainframe that's generating credit card events and transactions, and it's generating hundreds of millions of transaction events per day, and that stream now needs to be published over an API to other people. So publishing and capturing that stream is a part of the task, which is fine. But then when we're delivering it over the API, when somebody's getting that credit card event, they might also want user.id, user.email, user.info, right? You want authorization to make sure that if I'm looking at a transaction and I'm the account manager and that can actually view that transaction, I have the ability to access that, right? So it's that kind of same problem that we have with data, but now applied to an entity inside streaming as well, right? And then of course, you want this whole system to scale out, right? So when we kind of think about introducing this capability in Hasura, right? What we did was we kind of reduced this problem on 2 dimensions. The first is GraphQL. I mean, using GraphQL as an API is nice because especially subscriptions is a nice API. It's WebSockets. GraphQL is a convenient way to fetch stuff. You don't have to care about how it came to be. You have a GraphQL client and you're able to at least, and then you have a GraphQL server. It's over HTTP, it's over JSON. So some of the base plumbing starts to become clear, right? But then the second step was that we reduced the streaming problem to a basic set of primitives. And for those of you familiar with Hasura, most of us here on this call, that's kind of the approach that we always like taking, right? We always like reducing things to a basic set of primitives that are then composable, right? So in this case, the actual basic set of primitives, the task was to say that, hey, we want to solve some of those functional problems that we discussed. And we want to automate that part of that API creation problem for streaming, right? And so what we did was we said, because we want to keep composing our authorization and relationship stuff, what we reduced this problem essentially to a range scan problem, right? So we said that if we have a model and that model is essentially, let's say, the stream model, then on top of that stream model, the streaming problem is essentially an efficient range scan and being able to pull incremental ranges of that data. That's what we're going to take a look at. And now once we have that model, the stream model, all of the Hasura features around authorization, relationships, etc., will just continue to work, right? And the streaming primitive becomes incremental range scans that are as efficient as possible, right? We're going to talk about kind of how that works in a second, right? So, and then from that's the demo. That's the demo that I'll take you folks over. A few notes on the consumption side of the stream, as you think about using streams, is that one, from just kind of an approach point of view, right? Any streaming, independent of Hasura, the way that you would think about consuming a stream is a consumer opens a connection, right? Forget applications, backends, whatever, right? Any system that's consuming a stream, the stream consumer opens a connection. The stream consumer quotes their offset. So they say, hey, I want to start my stream from offset 12. And then from offset 12, you start getting the stream, right? And you get ordered data from that offset. And the customer, the streaming customer, the streaming consumer, the API client, it commits or stores that offset so that in case something goes wrong, it's able to recover from that offset value. This is fundamentally any stream producer and stream consumer, right? This is the fundamental way that they would communicate. Important thing to notice here is that there is some amount of state, right? The onus is on the client to store state about that, about where they're reading from. Notice that in the live query model for subscriptions, we didn't have to store any state, right? We just said, you just subscribe and you get the latest value, right? If it changes, you'll get changes, but you won't get the changes, you'll get the changed latest value, right? And that way you don't have to store any state on the client, which is convenient for a lot of use cases, but doesn't work for cases that are just true streaming, right? Where you do want to get a large streaming data or where you want to pull in a large amount of data, right? And so there is now a piece of state that has to be stored in the client. The client can actually store this again back on the backend system and say, hey, here's my latest offset. So, if I close the application and reopen it, I'm going to just fetch my latest offset from the backend first and then start reading from that offset, right? So, but it is now a problem that the customer does have to solve. So it introduces that element. But if you have that element, then the customer can start kind of consuming that stream. You'll see the same idea everywhere. You'll see the same idea whether you're consuming from Kafka or Redis or directly at a backend service. You'll see the same idea of an incremental range scan, plus having offsets if you're using a system like Cassandra. For example, Discord, they had a really nice blog post. Just like my slides will have a link to it, of how they built kind of their chat message system that would scale across threads with Cassandra as an underlying system, right? For being able to shard on that, on a message ID or a message channel ID. But exactly the same idea of having an incremental range scan that is easy and fast to consume, and this idea of having an offset. So so when we kind of now take all of this together, let's take a look at what this looks like with Hasura. So what I've done here is, and this is similar to a demo that you might have seen earlier, but I have no idea why I chose this particular model. But here it is. It's colors, and it's like color-coded messages essentially. So the color represents a channel. So there's a green channel and a red channel, and then there's a message, right? And so I set up an authorization rule saying that people who belong to a red channel can only see, I'm going to have something called a user ID, which is red. So if my user ID is red, I can only read from the red stream. If my user ID is green, I can only read from the green stream. Again, I don't know why I call this colors, but there you go. And this particular model has, it has like about a million messages, and in this live demo, I'll be adding about 100K every instant or every second or so. And then we'll stream that, right? So this is my model, right? Normal model. I've also set up an authorization rule, which is based on this channel name or color name or whatever you have. The important thing is that from a Hasura point of view, the job of how the data gets into this model is not what Hasura is solving. Somehow you have to make sure the data gets into this model. Once the data is in this model, Hasura will make sure that you get a streaming interface to that model, right? That's the approach that we're taking here. So just to show you what the API looks like, what you would remember is our live query API, which was something like saying, hey, I have a color and that has an ID. Let's subscribe to message. right? And if I go and change that message, this is just normal subscriptions, right? Where I'm looking at the live value. Let's sort this by ID descending. Oh, oops, I added a bunch of data. Let me fetch this particular value here. All right, so ID equal to, right? And if I go change that to new message, right? You're subscribing to that latest entry, right? But this is not particularly great if you wanted to subscribe to, there were messages that were happening on this channel, on this model, and you wanted to kind of stream these messages as they were coming in, right? That's what you want. And this is not particularly great for doing that. And in fact, that's kind of one of the top kind of user requests that we've been looking at, is basically saying, if I want to model this kind of a system and I subscribe to this, the challenge becomes that if you start subscribing to the entire colors model, you're going to get a JSON response that contains 1 million elements. And so even if one element changes in the million, you're going to get the full million again, which is not useful when you're looking at such a large list. It's useful when you're looking at a small element or one element that has a nested object and nested list, but it's not useful otherwise, right? So now what we're looking at is a streaming interface. So let's take a look at what that looks like. So I can say subscribe to color stream. And let's see what our latest ID here is. So we can get ID descending. All right. So I have this value here. So this is what the stream API looks like. I can choose a batch size, which is the size of each payload, each WebSocket payload that I will get that contains this amount of data. And then I choose in kind of my initial offset value. Right, so I choose the initial value of my offset that I want. So I'm going to say it's this because that's the latest element that I have. I can also specify an ordering if I need to, but in this case, the ordering by default is just, okay, perfect. And so let's start subscribing to this. And you'll see that it's kind of, there's nothing in here because this is the latest value. So there's no, the stream is active, but there's nothing kind of coming in here, right? What I'm going to go do here is I have a load script. Right, and I'm going to load like, I think I'm loading in like 100K rows or something like that every half a second. So let's load that, right? And so as soon as I do that, you'll see that this thing kind of starts streaming continuously, right? So it's decoupled. The data is kind of gone in, and that can go in at its own pace. And this stream is now kind of streaming from this with that initial cursor, right? So now if I stop this, right, as a client, let's say I stop this because maybe there's a back pressure problem, or maybe I get disconnected. The next stream then should not continue from this value. The client has to store the latest offset, right, and then continue from this offset. Right? Let's bring in a color here so that we're seeing some data, right? So this is kind of how this piece works. It's fairly straightforward to integrate because it's just GraphQL subscription. It's super easy to integrate this on app as well. You're seeing that I had this app running, which is why it's kind of starting to stream data also. So if we can try this out live if you folks want. So head over to this link, and then randomly you'll be assigned a red channel or a green channel. And if you type in things, you should see that here. So right now I'm on a green channel. So everybody on a green channel is going to see a message. Eggs are green eggs and ham. Green eggs and ham. There you go. Eggs, right? And now this is now a stream, right? As opposed to, this is not like the live query model where we're getting the latest value and then doing a requery, or we're subscribing to the whole thing, right? Cool. So this is kind of how you'd see that, right? And you'll notice that those folks who are on the red channel are only going to see red messages, right? And if I spam you all by running a load, I'm not going to do that. A bunch of data will start flowing into your public feed, right? And if I refresh this, right, I'm just going to pick up from the latest. I'm just picking up from the latest offset. So I'm not seeing the older ones, right? This is just the way that the app is constructed. You can, if you want to, you can start incrementally streaming older stuff too, right? So that's kind of how, so that's kind of what this piece looks like. Very, very excited about putting this together. We're putting a little more content about how this works really well with being able to scale this out massively by the cursor column that you have. You can use that as a shard key essentially. And if you use that as a shard key, you can start horizontally scaling out as well. And the same pattern that we have here works across all types of data systems. This is built on Postgres, and you can do Citus and Yugabyte and stuff like that right now. And as we kind of expand to support other things from the Postgres family and other databases, the same pattern will continue to work, right? So that is a quick look at streaming. Yeah, that's all I had. I'm going to hand that off and hand it back to you, Jesse. You've taken up a lot of time, and I'll take questions on chat.
Definitely a fantastic feature and a really, really cool demo. So yeah, you can see a lot of implications of where that would be super useful. So thanks for showing that off. First talk up is actually going to be from one of our down under colleagues. And so they decided that maybe it's better to just record it when they're alert and not when it's 2 a.m. So we're going to go ahead and have a quick look at the multiple JWTs. This is a really great talk. There's so many useful pieces in here as well about tools and tips about working with JWTs in general. So I'm super excited for it from Lyndon. So we're going to go ahead and have a quick look at that.
Hi, everyone. This is Lyndon. I'm a backend engineer at Hasura. Today, I want to introduce you to a new upcoming feature that we're calling multiple JWTs. So historically, you've been able to configure one JWT configuration with GraphQL Engine. But coming up for pro and cloud users at least, you're going to be able to configure more than one JWT configuration. So that's what this feature is about. I'll give you a little rundown of some of the kind of motivations and use cases, then some technical details about how they're resolved, and a little demo. So first off, just in terms of why someone might want to use this feature, there are a few obvious motivations, but then there might also be plenty of other things that are not listed here. But the top ones would be rollover. So if you wanted to kind of like update your configuration, rather than having to flick a switch and have all of your users kind of switch over to the new thing synchronously with the change, this will now let you kind of do a blue-green style approach where you could add the new configuration, then in leisurely pace migrate all of your users, and then once they're all migrated, you can turn off the old one. So that's a very common pattern for other things that now can be used for JWTs. You might also have kind of multiple JWT providers that you want to be able to run in tandem. And then you might also want to be able to kind of pool your users according to some JWT mechanics, which can be powered by a feature like this. Then in terms of so how is a specific kind of configuration selected if a user is kind of submitting their token? So there's in the JWT configuration, there's kind of like two parts of the configuration that are relevant to this. There's a header part of the configuration. By default, this is the authorization header, but it can also be done explicitly, or it can live inside a cookie under a certain name. So when you submit your token, if you submit it under the kind of matching location specified by a configuration, then it will become a candidate. Then there's a second kind of refinement done to determine whether it's relevant via issuer. So when you have your kind of JWT generated, you can have an issuer field present. And then you can also have an issuer specified in the configuration. And then if those two match, then that becomes a valid token candidate. If the issuer is missing either from the token or from the configuration, then it's ignored in the corresponding token or configuration. And it will just simply use the header location to determine whether it's a valid candidate. And then finally, once you have your token candidates, if you have 0, then you just do the normal unauth flow. So if you have an unauth role configured, it will use that. If one is found, then the token validation flow is performed. And then if more than one is found, currently that's an error due to the ambiguity of the situation. So we won't try and validate multiple kind of token candidates. We'll just return a kind of ambiguity error. I'll give you a little demo now. So if I switch over here, what I'll do is I'll run pro with two JWT configurations specified. So here's one, and then here's another one. So if I spin this up, we should be up and running. I've generated these, by the way, by another team member's little tool called JWT config generator. But there's plenty of ways to generate these configurations and JWTs, especially if you're already familiar with using single JWTs. So with that up and running, I could kind of run some curl commands, but what I'll do is I'll jump over to the console that everyone will be familiar with. So I've got some data set up in a table, just with two little IDs. I'll show you the data now. So if you have a quick look in the foo table, then the permissions, you should see that we have kind of a few roles set up. I have the normal admin role that has all access, and then I've created a badmin role that has some filtering performed on the rows, sorry, which just checks that the role matches. So if we have a look at the data, then you should see that the role is specified here, so that's going to determine what's selected. Yeah. So as the normal admin via admin privileges, you can select all roles. But then I also have two of these JWTs tokens set up. So we'll use the first one here, and that should allow admin role access, which once again can select all the rows. And then we'll also then have a second token set up, which allows only the more restricted badmin roles to be selected. So I'll quickly show you those tokens. So here's the admin one with the admin role allowed and by default. And you can see here that the issuer is set to Hasura. And then we have the second one with the badmin role allowed and by default. And then here the issuer is set up as Google. This is just a string. It's not actually either issued by Hasura or Google, but I've just set them up for testing purposes like that. Yeah, then if we have a quick look over at the configuration that was generated, you can see there's the corresponding Google one here and the corresponding Hasura one here. So that's kind of it for the demo. So hopefully that gives you a little bit of an idea about how this could be used. And so I'd encourage anyone who has a Pro or a Cloud account that can access Pro features to give this a go if it seems like something you might want to play around with or potentially use in production. Let us know what you think.
All right, so that was a great demo, and there was a lot of really cool tools and tricks in there that I actually learned a lot from when I watched it. If you have any questions for Lyndon, do also post them here in chat. We will try to answer them as well. If not, we'll pass them on, and we will be sharing a copy of those slides to everybody because there's some ISP load issues that are probably causing some blurry streaming. So apologies for that. There is one question that I saw: when will multiple JWTs be available on cloud? Now. Like they're up, so they're available as of today. So feel free to play around with those and let us know what you think. The next one we're going to be having today is on the better comments for schemas, which is a great new feature we're excited about. So we're going to have a quick look at what that feature is all about.
Hey all, I'm going to give you a quick tour of our extended support for comments in your GraphQL schema. So HGE already supports putting descriptions on things in your GraphQL schema, and if you look at the documentation explorer here in the console, you can see that we already auto-generate comments for things in there. So for example, we've got our root field here and we've auto-generated a comment. If we go into the actual user itself, we've got an auto-generated comment here, so this is the type that represents a row out of our user table. You can see we've got some comments on columns here. We've got comments on computed fields, and so we already plucked some of that information out and displayed it in the GraphQL Explorer. Now, what you may not know, or maybe you do, is that for a lot of these things, we will also look at the comments that come off your database as well. So if we set a comment on the table in our Postgres database, we will automatically pull that comment and put it here in the GraphQL schema documentation. And if you put a comment on your columns, we pull it out and we use it here. And if you put a comment on the function that backs a computed field, we'll use it here as well. Now, that's all very well and good, but what if you don't want to use the comments that come off your database in your GraphQL schema? So perhaps those comments on the database are written really for your DBA types and aren't really appropriate for your GraphQL API users. Or perhaps you just don't want to leak your database schema details out to your API users. You want to have properly described descriptions for your API. So previously you couldn't really control what HGE did. We either auto-generated or we pull it off a comment off your database. So now you've got the ability to be able to control these GraphQL descriptions by setting explicit comments in your HGE metadata. So we can see if I switch over to the data tab, we've got this user table here. It's very standard. We've got a bunch of columns on here. And now if we switch over to an API view of this, this is kind of how that table is configured in the metadata at the moment. So we've got our user table, we've got some custom root fields, we've got some custom column names. So now what we're going to do is we're going to customize the comments with some new fields that we've added to the metadata. So we can add a comment here at the table level. Sorry, that should be here at the table level under configuration, and this comment will be used on the table object. And we can also set comments for all of the custom root fields as well. So for example, we could customize this one here, and now we can customize more than just the name. We can expand that out to an object, and we can set a comment here too. And the last place in here in this API call we can set comments on is on columns. Now, we previously had this custom column names property. Now we've deprecated that and we're replacing it with the column config property, which lets us be a little bit more extensible about the sorts of properties that we can set. So here now we can have a custom name to retain our existing surname custom name, and we can now add the new comment to that particular column, and so we can get rid of that old custom column names property. Now we still support that custom column names property, it's just deprecated. So if you are using the API, you'll probably want to start switching across to use the column config from now on, but for now we still do support it. Okay, so if we run this API call, that will set. We can come back to our browser, and if we go back to API, go back to our query root and have a look at user. Hello, look there on our root field, we've got the comment that we set from the metadata. If we go into here, We've got our comment that we set on the row type, and if we go down and we have a look at, here we go, our surname. There's our column comment. Now there's one more place you're able to set a comment on, but it's not on the table. We don't do it on the set table customization, and that is on computed fields. So computed fields actually already have a comment property, but previously up until now we haven't used that for anything other than just a comment that you can see in the console. But now we're actually using it to populate the description in your GraphQL schema. So if you set this, so if we set it to of the user, and so this is just going to drop the field and add it back again. And we go away and come back to this, refreshes, go back down to our user and have a look at our computed field. We can see our comment is now used there. So now I've demoed this feature using the metadata API directly. So out of Insomnia here, just doing the API calls directly. And that's because we currently don't have support for setting these comments in the console directly yet, except for computed fields. That there's already a field there for that, so you can use it. But never fear, we are actually working on support for setting this stuff in the console, but we've shipped API support first, and the console stuff will come later. Yeah, so that's it. I hope you've enjoyed this little demo, and I hope you'll go off and use these new features and improve your GraphQL API schema for your customers. Thanks.
Right. That is a really fantastic tool. And if you've been using any sort of GraphQL front-end tooling, you'll know just how important a role those comments actually make. So that's something that we're really excited about. And the next one we're going to be having a look at is actually a feature for those using REST connectors. And now we have an ability to make connections at deeper levels with relations, which is another really powerful feature that we'll be having a demo from David.
Hi, my name is David. I'm a developer at Hasura. Today I'm going to be demonstrating a new feature that we've recently developed called nested action relationships. To demonstrate this feature, I will show a small example. First of all, I've got a Postgres database set up here with a table called AuthZ. My table has a couple of columns, ID and name, and I've populated it with a couple of rows of data here. I also have a little HTTP service here, which will return a user and the ID of their favorite author, but it's nested within this favorite author object here. If I run that service in curl, you can see I just get back the object here with the user name and their favorite author and the ID. Now what I'd like to do is join this ID value here with the authors table from Postgres, so I can fill in the name of the author here. Now, previously this wasn't possible in Hasura because we could only put relationships on the top level fields of the object type returned by the action. And here we've got the ID is nested under this favorite authors object. So we weren't able to do that. But now we've added support through the API to do that. We don't have console support for adding this yet. So I need to add it through the API. I'll show you what that looks like. So in the API, we can set up some custom types to represent the types returned by the action. So first of all, we've got the top level user type, which has the username and the favorite author, which has a type of author ID. Then the author ID type here has the ID field, which is an int. And we set up the relationship here to say that we're joining that author ID from here to the ID column from the authors table. And then we need to add the action here. I've got specifying the user output type here and the handler to that little web service I set up. So I have run Postman to set this up in Hasura. I go back to the console here, and you can see we've got this is the user field set up for the action. We've got the username there. We've got also their favorite author, and within that we have the ID, but we also have the relationship to the author here from the database table. So if I run the query, what I get is the name of the author, which has been taken from the database table here. And that's all I've got to show today. Right, thank you.
Yeah, I'm a huge fan of nested actions, and this is a functionality that really is going to come in handy. So now we're going to have a look at the latest Prometheus integration and a bit of a deep dive on how that works. And Sandeep's got a really fantastic demo for us.
So basically, what this feature is that it allows you to export Hasura metrics to your Prometheus instance for monitoring and alerting. This is available in Hasura Cloud and Pro editions. So basically what it exposes an endpoint which can be scraped by Prometheus to get the metrics. Basically, it's just another integration like the ones that we offer for Datadog and New Relic. So let me go ahead and create an integration. I'll just create an integration having a namespace called test. I'll enable this and I'll set up Prometheus to query from it. It's basically using a basic auth header with username being the project ID and the password being the access key that Hasura generated for you. I'll bring up Prometheus and Grafana. It's running in it's going to be running in Docker Compose. So now my Prometheus is scraping data from this Hasura project. Let me just quickly run a load gen tool to generate some requests so that we can see the metrics. So yeah. So basically what we are doing is we are scraping this endpoint with a header, which is just the username being project ID and the password being this access token. So let me use those values in the basic auth header, and I can see, so Hasura exposes 5 metrics as of now. So it'll tell you how many requests are coming in, what's the execution time, how many subscriptions, WebSockets, and what's the success percentage of all of them. So this is what this endpoint gives you when you authenticate with it. So let me open Grafana where we can chart this. I'll add the Prometheus instance as a data source. I'll import a dashboard for this metrics. It's custom made for Hasura metrics. So you can see basically these are the 5 metrics that Hasura exposes: the number of requests coming in, their average execution time, number of active subscriptions, and the number of WebSockets being open for supporting all those subscriptions. And for now, all of my requests are running back with the right responses. So basically, you can start setting up alerts on these metrics, like if the success percentage goes less than 80%, or if my average execution time exceeds, I don't know, 5 seconds. You can start setting up rules in Prometheus or Grafana or any tool that you want to use. And this can be used to monitor the health and the performance of the Hasura project.
That's so fantastic. We'll let the questions come into chat and you can answer those there. Thank you, Sandy. That was a really great demo. As a product person, I love charts. So seeing that all come together, that's a really cool look. So I really appreciate that. And Prometheus has been one of the most requested integrations. It is a cloud level integration because it requires server level access and different details. So the integrations are specifically for those click and like making it that easy. That is a cloud level integration, but all of these functionalities could also be spun up on your own homebrew server as well with the OSS edition. But thanks again for that. With that, we're going to move right along because we're getting really close to the end here. So moving on to our community champion demo from Chris Nurse, another Australian, the last Australian for today. But we're going to have a really great demo here. He's got a really fun presentation, and then we'll wrap it up after that. So enjoy this demo here.
Hello everybody, my name is Chris Nurse and I'm the creator of an open source project called QuickTrack, which enables us to rapidly configure Hasura. I was recently announced as a Hasura community champion, and I'm incredibly grateful for the opportunity to help to support the global community, and also I'm very thankful for this opportunity today to tell you about my open source project. My career spans around 46 years, so I don't have time to bore you with all of that immense detail. In 1978, my dad, who was in a band as a bass player, also hand-built the first computer that I ever learned to code on. Dad literally launched my technology career, and he also gave me a passion for music, as I also took up guitar as well while I was quite young. Anyway, fast forward through many years. In the 80s and 90s, I was a Unix system admin, used to code in C, C++. In the 2000s, I was in consulting and ran a research and development company in Spain. And then I arrived in Australia around about 2002 and helped to build 3 IT consultancies here. The pinnacle of my career, though, I feel, is in 2014. I was given the role of Chief Technology Officer for the Telethon Kids Institute. Telethon Kids is one of the most recognised child health research organisations in Australia. When I finished my project there, I was named as one of Australia's top 50 technology leaders, so I was very proud of that. Fast forward to today. This year I just took a new role as Chief Technology Officer in Chrysalis, and in Chrysalis we're really seeking to help startups in the medical device, medical research field get through a phase of rapid growth. So we're very excited to have several projects underway this year that really focus on people's health and well-being and support clinicians and researchers to work faster and smarter than ever before. So what is QuickTrack, and why should you even care that it exists? To answer that question, I need to tell you a very quick story. Once upon a time, there's a handsome prince, and he has a princess that wants him to build a castle. So he needs some kind of design, he needs to clear some space, gather all the materials together, and then get the foundations laid down, build the thing, and then ultimately one day the project is going to be done. That's not unlike building some kind of app, or in my case, I often build prototypes as quick as possible. And I use containers, I use databases, I have a data model to tell me what kind of information I'm working with. And there's some kind of configuration that sits across all of that. And then I start building the prototype, and at some point I can hand that off to a development team. And what helps me go faster is the fact that I can choose all of these off-the-shelf technologies. Docker for our containers, Postgres database, have a SQL schema that dictates my data model, and then Hasura, and in particular its console, so I can start, creating tables and building this GraphQL configuration. But that starts to get painful when you have to iterate hundreds of times when people change their minds or want to push the prototype in different ways and add and delete tables and all that kind of stuff. So what we really need is as many tools as possible to help us automate. And of course, there are lots of tools around that help us automate different things. And QuickTrack is the clue as to what QuickTrack actually does. It lets you very quickly set up all of the tracking in Hasura in a consistent way. But you're probably already saying, hey, Hasura already does set up tracking and it's pretty quick. I think it's like a couple of clicks, right? Okay. So to get started, we basically need to pull the QuickTrack repository from GitHub. And then the first couple of things that we're going to see is that there's an example database, and in there's a script to create the database and another script to insert some test data. So in order to have a database in the first place, we need something that will create the database and also give us an instance of Hasura. So let's run this npm command down here that starts up the back end. Okay, so that's now good to go. So here's Hasura. We can assume in the background that Postgres is running because Hasura is connected to it. So the next thing we need to do is clean this up and get our database creation script. We'll run the database creation script, but we won't track it. Let's just say run. Clear that away. And now seed the example data and run that. So when we look at our data model now, there's a membership schema that's been created, and in there are quite a few tables that help us create a database for a membership management organization. So membership organizations have members, and typically those members are in groups, and they have some kind of status like active or cancelled, and some kind of role like normal member or group leader, something like that. So in 2 clicks, we can just say to Hasura, yes, please track all of my tables, all of my relationships. So that now I can go back and start my first query, which will be using membership groups. So when we look at our groups, they have 2 groups, one called Group 1, which is in Western Australia, one called Group 2, which is in New South Wales. Now, who are the members in each of these groups? Okay, so we can see Jack, Jill and Barry are in Group 1 in Western Australia, and Sheila, Angela and Ben are in Group 2 in New South Wales. Now, one of these members in each group is appointed as a leader. And I know that because when I look at my membership groups, I can see that there's this leader ID. So it should be pretty easy to say who is the leader. And no, I can't, because it's actually showing me the native column in the database. What's actually happened is because the leader is a member, by default the tracking has been set up to use an attribute name, if you like, of member rather than leader. So if we just assume we've got member here for a moment, so we know that this leader is Jack for Group 1, and we know it's Sheila for Group 2. So our tracking information isn't intuitive. I'm thinking as a business person who helps this membership organization. I know I've got groups, I know I've got members, and I've got leaders, but somehow I can't see them in my data model. So this is where QuickTrack comes in. All we need to do now that we've got the backend running is to run this QuickTrack CLI. And what it will do is it will pause for a few moments just to make sure that the database is up and running and that GraphQL and Hasura are all available. Because imagine you've done this as part of a Docker Compose. These things happen so quick. One step of the setup process has to wait for the previous one to complete. So let's just crawl through this bit by bit. So QuickTrack ran. We saw that it connected to a database called QuickTrack and a schema called membership. That's in its configuration. We know it talks to Hasura GraphQL on port 7123. And we're telling it that our preferred standard in our database is that primary keys end with _ID. So now it's super easy for it to know how to build relationships with logical names so that leader ID can be a relationship called leader simply by removing this _ID from the end. So what QuickTrack did also is remove all of the old tracking information that was in place, either by you doing that manually or Hasura doing it automatically for us. It just gets removed. And then after using the database creation script and the database seed script, it's built the database, populated it with data, goes through and then tracks the tables, which is pretty standard, but it hasn't put the schema name on the table name, so it's a little bit more intuitive and efficient in that sense. And then it goes through and it adds all of the relationships. So let's have a look at what that looks like in Hasura console. So first thing that we realize is that membership groups is now just called groups, and this member can now be called the leader. So when we run the same query now, we've got all of our data and I can clearly see my leader is Jack. I don't have to kind of reinterpret or remember somehow. And I don't have to use aliasing. So we could have called members, we could have said to GraphQL, please rename that field for us as leader. So as you can see, in just one simple step, we can use QuickTrack to run our database creation script, populate the database with data, and then automatically set up all of the tracking with completely intuitive names that are guided by the names of things in our database. I think what I'm going to do is wrap up there. Really, I think it's up to the community now to give us more guidance on QuickTrack. Is it just something that's useful in a prototyping context? Is it really useful when you're working in teams where technologies are already selected and now we've got a standardized approach to introducing GraphQL against our backend databases and so on? I really would love your feedback, so please do provide lots of comments, and I'm sure we'll keep improving QuickTrack in the months ahead of us. Thank you so much for watching, and I hope to hear from you all soon. Bye-bye.
All right, that was a great demo, so really appreciate seeing that. It really underscores that one of the most important parts about working with Hasura is that you get your data model right. And it's a part of the story we hear over and over and over again, that starting with that data model ahead of time, everything else just sort of flows from that and becomes a really powerful way to work. So really great demo, and love seeing that. I'm going to wrap this up here real fast because we're just a bit over time. Some quick updates. I want to just call your attention to the Data and API show. Happens every Tuesday at 10 a.m. Pacific. We have a brand new landing page. If you go to /community, you can find access to it there. But the last show, we had a talk about a virtual integration that we have in the works. The next show, we're going to be having a deep dive on the Hasura Super App. If you are not familiar with the Hasura Super App, it is an amazing reference piece that basically covers everything you could possibly need to know about working with Hasura. And we'll be going into a whole series over the next month on that topic specifically. So it'll be a lot of really interesting time. Next piece is we have the GraphQL for the world coming up, GraphQL for everyone. This is going to be the HasuraCon. CFPs are open. So if you have something to say or something you'd like to tell us, sign up for the CFP and propose a talk. It's something that we would love to see. And we're really excited about that day where we get to just celebrate the community and all the cool things that everybody is building together. Moving along, the next community call will be in April. The HasuraEd topic then will be migrations and metadata, which is all part of the CI/CD pipeline. It's all about how do you work with your data from a repository or other ways to work with your metadata. It is an integral part of understanding the real power features of Hasura. So I highly recommend you sign up for that one as well. And with that being said, we'd love to see you around the actual Discord community. This is where all of our chat happens and where you can ask questions or even help others out that are new to the community. Something we would love to see. And with that that's kind of wrapping it up. If you have any feedback for us, let us know about these different links here. And that takes us just 5 minutes over on time. So with that, I'm going to say thank you to all of our presenters. Thank you to you as a community for joining us. It was a lot of fun. And with that being said, we will see you next month at the same community call. Have a great one. Adios.